Okay, we're going to solve this very challenging paper 2 database question that was from 2010 paper 2 question 9. Now this is one of the hardest database question ever. So let's look at the question. Figure 1.1 shows a multi-mode optical fiber with glass of uniform refractive index. Okay, figure 1.2 shows 3 rays that is entering the fiber from air. Each of the rays follows one of the 3 possible paths through the fiber. Okay, so there are 3 rays. The first ray goes straight through, the second ray bounces a bit and then comes out, while the third ray goes and have even more bounce. Alright, so this is important. So the next information is that the 3 rays travel different distances and take different times to pass through the fiber. Figure 1.3 gives information about the 3 rays and their path in 2 cables of length 1 km and 2 km. Alright, so the first ray obviously only takes 5 microseconds to travel through because it's the shortest distance. The second ray takes a bit longer, while the third ray takes the longest because the distance covered is further as it strikes more to the side. So this for 1 km and this for 2 km. So the first question is, using data from ray 1 in figure 1.3, calculate the refractive index of the glass. The speed of light in air is 3 times 10 to the power 8. Now for this question you have to be very careful because actually there are 2 ways to solve for the refractive index. The most obvious way is to use ray 2. But ray 2 is our question. If you ever use ray 2 to solve for question A, you will get 0 marks. So ray 1, you will ask yourself, you can't use sine I over sine R, so what should I do? So remember, there's actually another formula which is something to do with the speed of light. So with this information, the way to solve this question is to first find the speed of light in the cable. So you can either use 1000 divided by 5 microsecond or 2000 divided by 10 microsecond. You will give you the same answer. So the answer is 2 times 10 to the power 8 meter per second. So using the formula that is less often used, n equal to c over v, speed of light in vacuum over speed of light in the medium, 3 times 10 to the power 8 over 2 times 10 to the power 8, you get 1.5 as the answer. Okay, so that's for part A. For part B, calculate the angle of refraction in ray 3. Now this is simple. Remember, it's entering from less dense to dense medium, so the only formula to use is n is equal to sine I over sine R. So rearranging the formula a bit, you will find that the angle of refraction is 22.5 degrees. So this first 2 marks should score, so you should be able to get 4 marks first. So the next question is going to be hard. Using data from figure 1.3, explain figure 1.4. So let's read this statement first. At time t equals 0, a single pulse of light enters the optical fiber of length 2 km. The pulse lasts 0.1 microsecond. Figure 1.4 shows the brightness of the pulse as it leaves the fiber. So the question is, why is there 3 pulses? So strange. As it leaves, when there's only 1 pulse as it enters. So let's look at the 3 rays separately. So what's happening is that when there's 1 single pulse coming in from the left side, okay, it's just 1 single pulse. But because they are coming in at different angles, it becomes 3 different rays. Okay, so this single pulse becomes 3 different rays. Now the first ray goes straight through, traveling the shortest distance, while the second ray has a bit of reflection, so traveling a longer distance, while the third ray has the most reflection, traveling the even longer distance. So since the 3 rays have the same speed in the same medium, of course the first ray will exit the cable the fastest, while ray 3 will be the slowest. So from this information and also from figure 1.3, as they have already asked to use, we can see that in the 2 km distance, alright, okay, ray 1 will exit in 10 microsecond, ray 2 in 10.3, and ray 3 in 10.8. So obviously 10, 10.3, 10.8. So that is the answer. It exits at different time. So maybe you can put in words. You can say that the pulse of light travels in 3 different paths with different distances covered under the same speed. So it will reach the other end at 3 different times of 10, 10.3, and 10.8 seconds. Right? So that's a very brief answer to a 1-mark question. So the next part is, okay, at t equal to 0, a single pulse of light enters the optical fiber of length 1 km. The pulse lasts 0.1 microsecond. On figure 1.5, draw the pulses of light as they leave the fiber. So for this question, it's a little bit simpler once you know how to do part 1. Since this represents the 3 pulses in 2 km, so if it is 1 km, it will become these 3 pulses. So if this 10, 10.3, 10.8 for the first pulse, for the 2 km pulse, then 5, 5.1, and 5.4 will be for the 1 km pulse. So from there, what you do is you just draw the same pulses, but from 5, 5.1, and 5.4. Make sure that they have the same amplitude. Apology for the hand-drawn diagram.